is the second exercises for Excel. So, the first file we deal with is this, page 1. It's about to calculate the cost for water consumption for a number of companies. Right. Initially, the base rate is 9 cents. Tariff rate is 7 cents. The cutoff volume is 100K. Right. So it seems that the more you consume, it's getting cheaper. But the company may consider about the environment factor and reduce the consumption. But meanwhile, they don't want to lose the revenue, so they try to consider different combinations of the price, the rate, the cutoff volume. At the moment, it's the first 100K will be set 9 cents. Above that will be 7, right? So, what about if we put different figures? So let's first calculate the cost of the water consumption based on the current rate. For the first company, so if B2 is greater than the cutoff figure, which is D 22, yeah, then it should pay for this part, yeah, the first 100K should be D22 times D21, yeah? Otherwise, it's 0, right? So we only consider consume above the cutoff figure, right? Something wrong here. D22 and D22 times D21. Oh, there's a bracket. Yeah, you see that? There's a bracket. It's not needed. Right. This is times 2. If B2 greater than D22 is D22 times 2 should be 20, not 21, yeah? Yeah, this is right. So this is the first 100 gallon of water. And for the amount of water above this, say, if B2 is greater than the cutoff figure is D22, yeah, or greater than that, then this bracket B2 minus D22. This dollar sign should be here, right? Minus this. So this is the amount above the 100 gallon of water. It times to the price of the tariff rate, right? It should be D21. Yeah. So this is this. So this is a B2 greater than this figure. If that is the case, then the difference between B2 and this cutoff will be the above, right? That is the rate of 21. Then if B2 is less than that, then B2 should pay the base rate, which is D20. Yeah, so that is the figure. All right. So let's populate for the rest of the company something like this, right? Yeah. Possibly those are not needed. Right. Now, the bill amount should be, for the first one, it should be B25 plus C25. Yeah? Yeah. And the rest should be this. So now we can use this to change a different rate. And we can also to sum of the total income for the company, right? Total income here. So sum, yeah. Oh, what is this? Where did this come from? No. We possibly don't need this. C2 to 15. No, we don't need this. This is a C2 to C13. Yeah. So this is a not C1, should be C2. C2 to C13 altogether is this. So that is the total income for the water company, right? And suppose if we change this from to 007, and if you concede more, and you charge more, right? So to see whether it changed the total income, we can have all very different combination. There's another way Excel developed is called a what if function. I did something before, now I deleted. Yeah, so we create a new one here. We create a new one. We called this as a scenario A1. Right? The change value is this. Right? Okay. So this is the current one. So if we change this to how about 8? See what happens. Yeah, so change something slightly. Okay, so that's another combination. Yeah. Or we have another one, A2. Again, the cells is this. So we change this. We change this to maybe 11. So what happens? We show A2. Yeah, we change. So through this, you can compare different options. Right. So now let's look of the page. So we go through page 1 and 2 now. We enter page 3, I think. Page 2, yeah. It tried to use data table. The one function for what if is data table. We trying to use this. So first, on page 3, there are 5, 6 instruction. First, in J1, they ask us to put something like 8,000. 80,000. All right. Then it's 120,000. Then what is this? Yeah, 110. Sorry, this is 110. 120. Yeah, that's it. And the next, they ask type the formula to I2. Type this one. So that is it's easy. We just type it. It's a B25 plus C25. Okay. So we done it. What is it? After we do this, so enter the formula. Use address. Okay, we do this. All right. Oh. At B22, where's the B22? B22. Oh, what is this? Then enter the formula, use cell address, in the copy formula, and so on. And then we enter this. Data. Where's that? What if? Yeah. Data table. Data set, that is the B22. Okay. How about I think we need to do this. Do this. B22. Yeah, I think that is one spot. Alright, that is the pivotal. This is what if. Now we move to pivotal table. Pivot table. Right, we use the second data set called Titanic. For now, you can ignore all the 0, 1, and so on. That is what I added earlier. So let's concentrate the first full column. We highlight this, we insert pivot table. So this is the data, create a new worksheet. Okay, we create a new one. So what we're trying to say is, can use this one, we can use that to see, to survive, yeah, to check which class. We can also display the result in different way. For example, we can talk about the percentage, right? And this percentage can be displayed in a number of ways. Yeah. Different ways. No calculation, grand total, row total, right? We can have this column total. So there's a lot of function here. You can try to display the data in summarize. So the key is here. The keywords here is summarize. Right. So what is this? This is this one, right? We don't need this. Delete that. Okay. So go back to this. For this part, this is I use the method of last week to analysis what would determine the survival, right? So in the real data set there are more, but for illustration purpose, here we use class, age, gender, these three. And we try to analysis, say, what kind of factor in term for surviving, right? Last week we have learned the method to convert this categorical data to numeric data. So as you can see here, so 1, 2, 3, 4, 5, 6, 7, right? There's 2 for age, 2 for gender, you can do that straight away. And there's something we add model. The reason we add this is we're trying to use the data set here to develop a model to predict whether this model can be used to predict the survival, right? So we try to compare this to model and survival. This model is artificial, right? Only for illustration purpose. And the model is pretty straightforward. It's on end of page 4. What the model says is that, you see, the model prediction is that female adult will survive. Clearly, in the first case, it's not, right? But this is only for illustration. You must be familiar with this term called confusion matrix. This is a quite important concept. In many hypothesis analysis, we need this. So, as you can see on page 5, what is this confusion matrix here is on the first column. It's actual survival, not survival, right? So that is a real case. On the top row, it says survival, not survival. This model, this is the prediction, right? In some other books, they would turn this around, so they put the actual on top, the predicted on the left. So there's 4 cells in the middle. As you can see what is the things in here is on the top left, which is actual survival yes, and the model 1 predictor also yes, so that prediction is correct. And also there's 4 cells. I talked about the top left, right? On the bottom right, this is the actual is not survive, and the prediction of not survive. So basically, that prediction also is correct. So there are 2 cases that are wrong. Say, actually this survived, right? But the prediction says no. So that is an error. That is on the top right among these 4. And there's another one. It's actually not survived, but prediction says it survived. So that's another error, right? So there's some to classify these two as type 1 error and type 2. So we, based on this data, make a simple model. It's a model 1. Here are 2 concepts I would like to explain. So we use the data, the original data, although we converted it, but they are the same data. So we use the same data to develop the model, and then use the model to test whether it's correct or not, right? So see, if I may, I try to, so there's a data set. It's like this, right? So we use exactly the same data to develop a model and also test the model. But if we have a lot of data, we could have something like this, right? We use the first part to develop the model, and use the second part to test the model, to see Yeah, now we make a comparison. Yeah. So that has happened very often in reality, and sometimes the ratio between the two can be different. Sometimes it's 1 to 10. Then you may say, what else can be involved in this? Well, in reality, people more often to create another color, or another set of data, for example, another set. So every time, you see, when we develop model, the more data we collect, the information will give you a better result, isn't it? I give you example. If you go make a mortgage application, nowadays, if you do that, they never see you in the branch, right? They always ask you to answer the phone or answer a questionnaire. And you provide the information, and they make a decision whether it gives you mortgage or not. So all this process is in the past they collect a lot of information. They develop you may call it a decider, right? So so they create a kind of a decider, then basically they develop a model, right? Then you add a new data set. They use the decider to decide whether you meet their criteria. If not, sorry, you are rejected. Otherwise, you get a mortgage. So here we talk about how to build this decider. Decider is based on the original data you trained. Normally, so when you verify whether the decider you build is good or not, they use, say, maybe in reality here, you see maybe you can have 3 of them as a trainer for training, and this is for testing. Then you compare this, the result, based on the training of that, you compare this with this, then you can say how many percentage is correct, right? And clearly, there are many different models can develop this decider, and you compare the result of your decider with the real one. In reality, this training data set normally is 10, and the test is 1. And also, you can keep changing. In the beginning, these 3 for training, this is for testing, or the next time you do this 3 for testing, this 1 for training. Sorry, this 3 for training, this 1 for testing. This 3 for testing, this 3 for training, this for testing. So they keep changing, and in order to develop a more sophisticated decider. So I believe that your lecture will later on to introduce more about what is a training set, what is a testing set. In fact, in here we use the same set as a training to develop this module 1, and we also use the same site as the tester. Yeah, the tester. So we have the same. Right. Now, so that is what the module 1 is about. And let's see, the module 1 developed is quite straightforward, right? It's very artificial, very for illustration. In reality, the model is much more complex than this. This is rule. But if you look at figure, it is female adult have a higher survival rate, but that simply is not good enough evidence to say this is a truth in every case, right? So now let's go to select this data set, right, and use this pivotal data to see what we can do with it. So basically, we try to compare this two yet, but we did some early. What do we do here is that, where is it? Just give me a second. Yeah. So this is the total of people, the grand total. Yeah. So this is this confusion and matrix we developed. So this is the model we created based on this simple rule: adult female survive. Right? So there's a real case. There is a estimated or predicted, and the total number is this. So this is the real. This is the estimated. So all right. So that is this exercises. Let me stop here. Thank you.